Yep, sorry, I was in another meeting and that was running late. Apologies, everybody.
No worries.
Did I miss anything in the first few
Oh,
minutes?
No, we
no,
were waiting for you guys. Yeah,
just a little chatter.
Yeah,
yeah.
yeah. I mean, I wanted to have this done for this week call, though. We're kind of wrapping up some stuff. The kind of big work, and I can go through stuff. Obviously, Melanie is on here, has been doing a lot of great work on the project. We also have had some other interesting open source contributions from Ewan, who's not on here, but has done some really good work as well. And so we have some really good open source stuff happening. Can talk through some of that as a general community call thing. More generally, in terms of the Homestar implementation, we're about a week off, some better README stuff as well from kind of the first demo application that people can run. It's essentially the demo that we videoed before, but now everyone can essentially run it. And we'll showcase essentially the ability to integrate IPFS with Homestar with like a small in-browser kind of relay application that will actually run a workflow over WebSocket. Not like standardized in terms of the format for like running kind of jobs through the browser and stuff. We're going to be doing some more interesting work on the in the JSON RPC side for having the ability to have. And we also have a demo that will work to showcase this from like the client as well, so you can run it through our CLI interface. So yeah, I think we'll have actually both demo, and I'll be releasing a video that we'll put on the GitHub page and spread around as well, and then people can run it. In this demo, and there'll be a little bit of forewarning here. Right now we are running from like what we call like a IPVM workflow configuration file, but it's based on a lot on the spec, which is not how people will typically write these things in the future, because you have to know how to convert things to like SIDs and stuff, which we really don't want to expect people to do more themselves. It's just where we are right now, of course, and kind of getting the whole kind of spec to compliance and reference implementation work going. But we have a lot of thoughts and stuff as we're growing the team now. For more user-friendly means for generating workflows and stuff like that will coming down the pipe. And I could talk more about that generally. The kind of big pieces that we're working on is kind of getting this runtime and this demo application up. Where Brooke, who's was on the other call with me, that's still going, has been working on. We're going through a lot of spec updates as well, as we're trying to kind of get the first early version of the workflow spec out there, which really is again this workflow piece around the UCAN invocation spec. The UCAN invocation spec is also going through some updates as well. We're separating some things out between kind of the UCAN IPLD, UCAN invocation IPLD variant versus the more general variant, because we don't have, spec wise, it's nothing is tied to IPLD, even though it's a major part of our implementation is kind of revolving around IPLD. And so, that those pieces are come into play. Yes, on the open source side, Melanie has been working done a lot of great work on incorporating some more of the P2P pieces that we're working on to kind of get a full networking demo that will probably come very soon, with implementing the rendezvous protocol. We have some other stuff updated as well in terms of having like trusted bootstrap nodes so you can run things, and we're in the midst, once all this stuff comes in, to actually run some of these, some early bootstrap nodes within the Fission space platform infrastructure that we'll eventually probably try to release some sort of closed alpha beta thing here in the fall for people to kind of try out. Something we're also working with on the infrastructure side with running all this stuff. And then, but people can also test, locally. We also have like Windows testing now. So we actually have Windows support for things. essentially minus daemonization right now. You can daemonize for Mac and Linux, but so yeah, a lot of things that come into play there for the runtime. Hopefully also soon, I've been ramping up back on some work on our IPLD to WASM interface type interpreter. And we'll try to wrap a lot of that up here in the next month. And we've been having a lot of conversations with the Bytecode Alliance people. That's actually been brought up a lot in various places. And, trying to actually having some good conversations with them to eventually, in some time, as Bytecode Alliances and different alliances take time to, get have some pieces built into it that would really help us out. They've been working on a map type, for example, and stuff like that will really come in handy. Plus some of the issues we've been facing with trying to have a really expressive data model to coerce IPLD again through to and from WIT. I explained a lot of our use cases recently, and they were like, "Oh, that is a good use case. Thanks." Now we understand. So, I don't know how long things will take on that side, but I think there's a lot of promising movement there. That's kind of the update from our side. Brooke just joined, of course. So I was talking a little bit about some of the specs that are coming into play. Our app, demo kind of app that people can run that's coming up soon. Some of the WIT work, some of the libp2p stuff that's coming in that Melanie's been working on, who's on the call, and some various other pieces that we've had in the open source community.
Yeah, amazing. Brian, and then I'll give my updates after.
I haven't caught up with this yet, but what is the rendezvous protocol that you mentioned earlier?
Yeah, it's essentially within the libp2p ecosystem. It's essentially a discovery mechanism, and so it gives us essentially a way, and the way the PR that Melanie has up right now that's been through review. Incorporates also this identity protocol, which we now use to essentially say, based on information that we can gather and discover, we can dial nodes. If we can identify nodes, then we can add them to the DHT that we share. And essentially, a lot of those moving pieces are in and around adding and removing peers, right? That we communicate with. This doesn't, as the work, and Melanie and I have been discussing this back and forth. There is in the rendezvous protocol, if you look at the spec, there's also a means to kind of discover things based on pub sub. We don't do this today. The Rust implementation kind of works a little bit differently in the libp2p. So we just kind of work around this identity protocol or identify protocol, that piece that connects everything together. With rendezvous that way. But yeah, so essentially you have like a rendezvous client and a rendezvous server, and essentially you basically make you express that I am this node that I want to rendezvous with other nodes, and then you have the client server kind of piece go kind of work back and forth that way. So yeah, it's essentially a service discovery protocol. So I'll actually link. So there's more in the spec than what's in the kind of Rust orientation of this library, but I think it's one that obviously I was much newer to these to IPFS in general, and there's obviously a lot of pieces like this. We've been using Gossip Sub for a while, but obviously there's all these other pieces, so we're trying to kind of leverage all those things. Then as I said in the code is like a whole swarm eventing with a lot of events. We still have some that we want to implement, or at least have logging around and stuff like that. So there's been a little bit of discussion through this also on which we don't do today, like explicit peers, which go bypass the scoring model. On the Gossip Sub side, do we do that? Do we not? That's some interesting decisions and trade-offs as we keep kind of building that piece out. I think it's like essentially with that stack with the P2P, there's a never ending protocol. But one of the big things is never ending sort of work. But one of the big things that we also have on the agenda there, as you know, Brian, is like testing a lot of that stuff and simulating a lot of the P2P stuff, which will come down the pipe too. Very much a internal need, but it's kind of the big part to make sure we have tested on a lot of fronts. I know Melanie's been doing a lot of work, kind of running on laptops. Hopefully, as we release this demo app and we probably release soon after that some sort of networked variant of that people can test out. We'll see more issues, but it's something we want to have kind of in-house testing apparatus that we feel pretty comfy with. There's a lot of variations to what might happen when nodes connected, not connected. Obviously, we have cases too where you have no gossip sub, you're just a single node. So can you run the workflow as long as you can fetch WAS and modules, stuff like that?
Gotcha. Thanks.
Yeah. Also, just to expand on that just slightly. So rendezvous protocols, plural, is like a class of thing. Of this kind of discovery mechanism. They often use, unsurprisingly, rendezvous hashing. I'm not sure if that's the libp2p one uses this as well, but it's we can probably find some articles and stuff that we could post after as well. Updates, just really quickly to get them out of the way. So I'm just looking at the agenda here that we had posted. Bastian probably posted this earlier, but I'm going to post it again. So let's start with the exciting parts, which is as a bunch of work inside of Fission is wrapping up. So for example, our encrypted at rest file systems going to 1.0, UCAN's going to 1.0, like, a bunch of these pieces are wrapping up. We're able to redirect resources towards IPVM. So Brian, who's on the call, as well as Quinn, who's for the past year and a bit been working on a database, is also going to be joining the Homestar team pretty much immediately here. They're currently working on UCAN stuff, but we'll be moving over to IPVM shortly. And it sort of makes sense, right? UCAN is a base layer that IPVM sits right on top of. There's I'm giving a talk at Strange Loop in about a month about IPVM. We should get some interest on the project as well, hopefully. And it sounds like Zishan may have a demo ready in time for that as well. So we should have some stuff up and ready for people to play with by then as well, which would be really, really great. And the final one, I've been on a spec tear with UCAN and IPVM. So again, we're thinking about this as one continuous stack at this point, even though they're in separate working groups. Cleaning up everything, getting UCAN ready for a 1.0 release, which then lets us get back to all of the IPVM specs that have been essentially sitting in PRs on hold for many months. Those can actually get wrapped up and shipped. And we have a lot more experience, hands-on experience now with this stuff. So we can take that learning and put it back into, okay, in a workflow, does this field make sense? That kind of thing as well. So that's to say there's a big push happening on the auth and invocation portion of this right now. That's going to 1.0, and that's going to become extremely stable very shortly here. Fingers crossed, end of this week, the writing will be done, and then we have to actually do the hard work of convincing everybody that this is the final version. And then we start locking down the formats above that, basically. We've also been hearing increasingly from, so Zishan and I were just on a call this past hour, and then some other teams as well that have been wandering in and talking about other standards in the space that are starting to think about some similar things, and so getting them involved as well. So IETF and W3C initiatives as well. So we seem to be, this whole project seems to really be on the sort of on the cusp of what is maybe a movement. There's this is a bit of a tangent, but between this sort of what used to be called mobile computing before there were mobile phones, so like, compute that can move around at the edge, and local first software, there seems to be something happening overall in those kind of spaces. And so this seems to be just very, very early work in that space that a few people are now starting to, or a few teams are starting to become more aware of and wanting to interoperate with. Those are my updates. Yeah.
Yeah, the one thing I'll add is people are obviously really in that front interested in a lot in discovery model, capability model. A trusted compute obviously is a thing that came up. Who can compute and can they compute? I think these are questions that we ask a lot, and particularly in this local, in a local first, but also just a general, like the decentralized landscape that we, ecosystem that we kind of are oriented toward. That's a major, it's a major positive that we can actually think about that, because essentially anybody can, form some sort of a means to compute along with you or along with this work, and that makes it somewhat more challenging at the same time, but I think also opens up a lot of the pieces that Brooke also gets to it will be in her stranger talk as well, away from the lock-in, a lot of these things, right? That we're kind of used to on the cloud computing front. So
Can I ask some more about what's meant by trust here? Is it like trust in the sense of like just a certain set of compute nodes that hold private keys and are signing stuff, or is it trust in the sense of we have SIDs for everything, and so we know people are gonna compute the right thing? Like what is trust?
Yeah. So kind of both. Like I think to a large degree that those are the same question, right? Sorry for anybody who's seen Wand triangles before. Wand's triangle before. Wand's triangle is this trade-off of essentially performance, privacy, and verifiability. So you can see them as a triangle. I'm actually relatively convinced that it's a square, but I haven't actually done the work to prove that out yet. And on the verifiability and trust portion of this, if you have your own infrastructure, so you have a PC at home that's sitting idle most of the time, and you want to, from your phone, push jobs off to it, you still need to sign it because you need to know that it went to the right machine, right? You fundamentally trust that it's not Byzantine, right? That it hasn't gone weird on you, and that there's no bug, right? Or nobody has broken into it. And you're just going to trust what you get back, and that's very fast. Like that's pretty snappy, right? In order to do trust of other workloads on other machines, you need to be able to verify them. And so two popular approaches to this are replication. So that's one way of seeing a blockchain is a very high replication system, right? Because everybody's going to run the compute, right? Or some huge number of the nodes are going to run the compute. You can narrow that down and say like, we're going to do 3. We'll run it. And if they all agree, we trust this. Could those 3 potentially collude? They could. So you can turn that dial up higher and higher, right? To make it less and less likely that they're going to collude. And on the far other end are things like snarks and ZKs in general, right? So you get an automatic proof out. That's not 100% guarantee that it was done correctly, but it's pretty close, right? It's like some huge number of 9s likelihood that this was done correctly. And there's a performance trade-off there as well. Those run much slower than just the raw computation. And all of these are possible, right? There are snark-based WASM executions or runtimes that exist. They're a little early, but like you can do it. And so in order for any of these things to work, you need to have context addressing, determinism, hashing, right? So they're kind of the same picture, right? There's some things that are much harder to verify, like sending an email. How do I know that it was sent and sent correctly? Like in concept, you could create this Rube Goldberg machine where, you know, you're checking with the recipient that they got the thing, and you have like, but you usually, we're assuming that they're not plugged into this whole system, right? So you need this flexible concept of trust to say, like, when I send an email, I really trust the email provider, right? As opposed to some deterministic WASM, you know, one-off job that you're never going to see again, where you probably want to have a higher degree of verification depending on how important the job is to you. And then, of course, there's this whole other thing at the data layer to say, you know, do I trust them to see my data, you know, all this stuff too. But it all becomes the same question in this model. So as soon as you start thinking about things in terms of capabilities, invocation becomes part of trust. But that's a whole other, like, we could do like 2 hours on that separately from this call. So.
We do link, there is a paper, 1 or 2 papers in the research repo about, you know, ZK snarks and WASM that we have in there. But yeah, you know, obviously, I mean, I think Brooke always says this pretty well, which is like, you know, it's a big performance trade-off. It's probably, we're not there yet, but the there has come much faster, I think, than a lot of people have thought, I think, for sure. So, you know, it's definitely, you know, it's on the immediate horizon, but it's in a horizon that seems fathomable, which I think is better than maybe like people 10 years ago would have said, right? So yeah,
and there's for the performance trade-off, because again, like if we're really focused on, I'm trading off trust for performance, you know, there's other trade-offs, cost, you know, et cetera, right? But like just pure performance, by bringing things close in space and saying anybody can run this snark for me, you're now not paying the latency, right? So it's like, how much of that job was going to be latency originally? Is this something that would run for an hour? Well, then the latency doesn't even count. It's a fixed cost. If it's a quick job and I'm going to pass it to somebody, you know, sitting next to me in the cafe, and they're going to run for me, I've probably just saved myself, you know, 200 to 400 milliseconds round trip time. Maybe that's sufficient, right? So the trade-offs are the you know, this multi-dimensional space of trade-offs becomes very complex. And so one of the really hard parts that we have not solved yet, in fact, I don't believe there's any perfect solution to, because you'll never have perfect knowledge, is knowing at what point it makes sense to even send a job across the network to somebody else and getting like an estimate on the, like, what is the trade-off I'm making right now? Should I race both of them? Should I start computing locally? And if I happen to get an answer sooner, I can kill this job. It's one way of doing it, but now I'm incurring at minimum like dollar cost because I'm asking somebody to take the job for me, right? So there's all of these questions about when to move the job off. There's research on this going back to, I mean, since the beginning of distributed systems, but the real sort of like meaty research on this starts in sort of like the late 90s, and nobody still has a real solid solution for it. Part of that is the halting problem. We don't know how long something's going to take to run. So gas kind of gets you around this a little bit, saying, well, I think it'll run within this much time. Are you willing to take this job for me, right? Or this many
with the trade-off,
rather.
like, are you? Yeah, I'm willing to pay it, right? Yeah, exactly.
Yeah.
I'm not solving the halting problem, but yeah, like, yeah, exactly. And also, I think, you know, I think another part of it is, to your point, I mean, a lot of the companies, you know, this goes back to the kind of, again, that general thing of moving away, or at least, you know, in a more multi-tier model where, yeah, you know, we're interoperating with clouds, but it could be homes, it could be, you know, other POP points of presence, right? This is, you see that majorly more in the Cloudflare Fastly Lab, for example. But, you know, I think when we see like the huge platform stuff or the huge distributed system pieces, you know, when they come out of particularly papers, this is either in like NSDI, OSDI, like networking systems, cloud, you know, like SOCC, these kind of cloud computing conferences, you see the big companies. For them, you know, the network latency they try to get around this. Well, they can just run them everywhere. They can put the money where the servers are, I guess you could say. And if you're running on their stack, sure, obviously doesn't care about countries that are not important. This is a big part of Brooks' talk. I think it's a really great piece, like in the Causal Islands version. And that's the thing. It's not fair in that way. Like, yeah, great. If I run on Azure, I run on AWS infrastructure, I can gain a lot of things. Lambda Edge, for example, has come a long way that I knew it from when they first launched. In terms of where they are, and so things can be pretty small. So if you're competing at that level and you want to be on the cloud level, it is different. But if you're looking at the larger landscape of, well, what is a fair means for like computing this thing, particularly in different countries, particularly across silos that might not have those major cloud, infrastructures that are there, then everything changes, right? And I think that's another huge kind of part of it, right? So because I think if you look at those, if you read the papers, there's a big paper that came out, I think recently, with some stuff around I forget which was the company behind it, but a lot of work that's been done even on the network switch layer and stuff. Well, that's great if you're running infrastructure for that company and they can showcase that stuff, right? Like it's not so great if you're at like a data center that has a much smaller footprint, or is some sort of private, semi-private data center, stuff like that, that people run things on. So. Any other questions? Things? Sorry, Bash.
No, I was just going to ask for anyone has any questions or stuff like that. Yeah.
Yeah, I think I will say for a lot of people, as we release, in the next little bit here, we release this application app, this relay application that again people can run and stuff. Obviously, it would be great to get this, make sure things work. This is not necessarily a networked demo that we're running, but it does. Yeah, it's networked in the sense that it will run off like IPFS and kind of write some things to IPFS as part of the example. And we're going to start doing more example stuff. It's a big part too of growing the team. And so I think we're going to have more and more of that, more and more different kind of variations, like most, like you see in most libraries or something, where we'll have start accruing more examples that we can run to showcase off different pieces. This is a little bit like an end-to-end one for running workflows, but as we start getting, we already have stuff in place around metering, constraints around memory, and fuel on the WASM side, for example. Again, this is very what is being released and what we're focused on is very pro this kind of deterministic WASM case. But we also have a pretty good plan for some of the first kind of effects that we're looking at, some stuff around IPLD block store for as part of an execution, and some other things as well. So I think we'll be iterating through a lot of different small examples as well, or take what's the example app and kind of modify it for different variations that we want to showcase, something like that, that we'll be doing for sure. Cool. I guess that's where we at.
Yeah.
Cool. Yeah. So we'll spread the comms when that app is up. If you're watching the repo, that'll be there. And as I mentioned in our call, I think we'll be releasing probably some small video clips that demo this, and this will be a part of some of the demo stuff that Brooke will show for Strange Loop, and
Yep. And just give people opportunity if they want. Also totally fine if not. It is August. A lot of people are on vacation. It's a slower time. We've been delivering a lot of information first half of this hour. If anybody wants to suggest use cases, want to build something particular with this stuff, now's a good time to pick our brains. You have Zishan on the call, actually, the guy doing the typing, and we can also you can always throw stuff in the discussions on the repo as well. Oh, and we have some stuff in the chat. Place to find more information. Yeah. So here, let me get you the sort of the reading list,
which includes specs. That's obviously a big part of things as well. And then obviously we have the Homestar repo, and I guess we can link. We do on the front of the working group. We have actually a bunch of talks and stuff. Presentations made, and actually link the exact link to presentations. There's a couple really good ones in here. There's a lot of the IPVM kind of before there was even code lineage presentations there, but in particular, two that I'll call out and I'll link. One is Brooklyn's seamless services for an open world, which kind of the early variants of the stringent one, I guess you could say. That's really just an amazing talk, personally, I'll say. And then one that I did a little bit more about the implementation and our references around durable functions, Ambrosia, workflow systems, where determinism comes in, replayability and all that stuff from the computer over data, one of the computer over data summits. Link that as well. Those are the starts. Usually when people are interested, I throw them those videos, and they tend to give a lot of good distilled information. I link the repo there too, Lindsay. So there's the Homestar repo. Yeah.
Wow, great, awesome, and thank you.
Well, thank you, everyone. If there's no any other question, we'll see you next time. Thank you.
Thank you.